building that we have, guys, has something called the boiler, the chiller, and the cooling tower. I'll get back to this one in a second. So here's your chiller. This is your chiller. This is your cooling tower. This is your boiler to get your heat when you need it. And this is your air handling unit. We can see that. So here's how the system works. Very simple, very easy. You have two closed loops, mechanically speaking, two chilled water closed loops. The condenser inside the chiller, guys, is a closed loop that goes to the cooling tower. So what they do here, they compress the refrigerant, and they reduce the temperature of that refrigerant right here in the condenser inside the chiller. And then when the refrigerant temperature is so cold, it cools the water because the water is touching the refrigerant, or the refrigerant is cooling the water inside the chiller. So it chills it removes the heat from the water inside the chiller. And then the refrigerant or the water, the one cycle goes to the cooling tower and remove the heat out of this happens to be the water here in the condenser. So there's water coming in here. So this is the first cycle right here. So what they do, guys, the first cycle is you have the water coming in here, going out, so you can remove the heat out of it. This is what the cooling tower does. So the condenser, pressure, increase the temperature, increase the pressure. The temperature will reduce in the condenser. By reducing the temperature in the condenser, guys, it will remove the heat from the water from this cycle. The cycle that's going this way removes the heat from it. It becomes hot. It goes to the cooling tower. When we go to the cooling tower, guys, at Allianz, at the top, you're going to see the water is dripping over the cooling tower. So the cooling tower's job is to cool the condenser, the water that's inside the condenser. That's closed loop by itself. Can you see that? Cooling tower with the condenser, they have their own closed loop. So the water gets chilled here in the condenser, and then it picks the heat. It picks the heat right in here, because they're in the same equipment. It picks the heat, and it takes the heat back here to throw it out in the other areas, right? So you're condensing here, picking the heat from the chiller, taking it to the cooling tower, and throwing it up in the air. And when you go to the cooling tower, guys, there's nothing but a big water pipe coming into a big tower with big fan throwing air right through the coil. There will be a coil here. The water goes to a coil, and they're throwing a mechanical coil, and throwing air right through it to cool the water and bring it back into the condenser. That's one loop. Any questions on this loop? That's when they say cooling tower. You guys have a cooling tower in our building. So in the roof, it's nothing but a big box, have a coil, a mechanical coil. A coil is a pipe, looped, and they throw big fans on the bottom, throwing air right through it. Sometimes they have water actually dripping on it, too. They're cooling that water inside the pipe to bring it back here, to pick more heat, take it back again, throw it up in the air, come back, pick more heat from the building, and that's how they chill the building, by removing heat from the building. Any comments, guys? Any questions? So here's your cooling tower, coil with condenser, and of course, what moves the water? Pumps. You have tons of pumps, recirculating pumps that take the pumps all the way to the cooling tower and bring it back again to the condenser to chill it, or to pick more heat, take it back, throw the heat out, and you keep removing the cycle of removing heat. This one will be outside. This unit is going to be outside unit. Any questions about this cycle? Any question about this? Here, my friend, this makes sense. So we remove the heat. That's the one cycle. The other cycle is another. This is the closed loop water system right here by itself. The other cycle, guys, is this. And you can see here's another cycle, another water cycle, two cycles. This one is outside. This is inside. Then they have a water pipe, and they shoot through pumps. They shoot the water all the way into the air handling unit. This piece here, this air handling unit. Inside the air handling unit, there will be a coil like this, and they send the chilled water, like you have seen the chillers. They send the chilled water into the coil inside the air handling unit. Jeff, inside the air handling unit, big fat blower that blows the air through the coil. There's a coil full of cold water, and you blow the air through the coil. What do you get? Cold water. So you get cold water here, then the water that went cold here, it will come back hot because it picks the heat from the room. Bring it back to the chiller, chill the water again, send it back to the air handling unit, blow air through it, pick up the air from the room, bring it back to the chiller, and it keeps going over and over and over again. Any comments, any questions? So here's your chiller. So you can see that your chiller has two components in it, right? Everybody can see the chiller. Here's my chiller. One component's going between the chiller and the cooling tower. That's with the condenser. And the other one is from the chiller into the air handling unit. So these two pieces will be typically the same piece. Any comments, any questions? Two separate cycles. Now what's your job and my job, guys, is to go power. I'll show you how this equipment needs power. This equipment needs power. A lot of these highlighted equipment need power, so we're supposed to power them. Any comments, any questions about the cooling tower interface with the chiller, interface with the air handling unit? Two separate closed loops water system. One water system going between the condenser and the chiller, inside the chiller body, and the other one from the chiller directly into the air handling unit. They don't interface these two water loops, guys. They're completely separated from each other. Can you guys see that? The blue cycle and the green one is completely separated from each other. Now, Jeff, in order to move the air, here's the room where your friend Chad is standing, right here. Nice looking young fella, right? Big ears. So here's where Chad is standing, right in this room. And now here's where you're pushing air. I don't know if you can see it. You're pushing cold air right in here. Okay? And then you're removing, and you're moving the air back into the chiller. So you can see the cycle. So here's a blower pushing the air through the coil. This will be, where's the fixtures here? These fixtures above your head. These fixtures above your head coming in and throwing, this one is the fixture right above your head. Throwing cold air into the room. And the return is coming back, taking the hot air back into the air handling unit to chill it again. Does that make sense? I know you guys are not mechanical engineers, but it's really nice to understand how most of the equipment that we did, HVAC equipment, are mechanical stuff, right? Any question about, guys, how the system is put together? We have a cooling tower to cool basically the chiller. And the chiller chilled the water and send chilled water to the air handling unit. The air handling unit, my friend, sends air through the chilled water, the coil. You got yourself cold, and then there's a return, the air return to the air handling unit. So you have supply and return to the air handling unit. Now, my friend, sometimes, almost always, the supply is going to be ducts like that above your head. The return in this day and age almost always is the plenum ceiling, right above, not this one, but the plenum ceiling above the suspended ceiling. That will be your return. You don't have ducts for your return. So you have a plenum ceiling. So that return right here, your return right in this area, that will be a plenum ceiling. Any comments, guys? And that will be the room that we're in right now. Supply air, return air. Any question, guys, about the cooling tower interface with the condenser chiller and the condenser chiller interface with the air handling unit? And in between, when I say interface, you can see all these pumps that's supposed to pump the water. That, when we went to Allianz, we went to Boston Scientific, did you guys see these big pumps that's sitting by the chiller and shooting all this cold water and hot water circulating into the system? Any comments, any questions? Any comments, any questions? Now, the last thing I want to mention is, now chillers, guys, not only, in the unit, they are called air handling units. Anybody knows what they're called air handling unit? Now, heating units or cooling units? Thank you. They handle both because they handle both. And then this is where the boiler comes in. The boiler comes in, my friends. Here's in the boiler. Now, in the winter, like today in Minnesota, you have a coil that you boil the water. Here's my boiler. I'm boiling water either by electric boilers or gas boilers. Typically, we have a gas boiler here. We're boiling the water here, and we're circulating the water back into another separate coil inside the same air handling unit, and we're blowing the same blower inside it. Blower now blowing air into the hot coil, and that's how we get your heat in a day like this in Minnesota. So the air handling unit, like the name implies, guys, it handles air, hot air or cold air. How do they make it hot or how do they make it cold? Very simple. They have a coil that's connected to the boiler that will bring you the heat, and a coil that's connected to two pipes that are connected to the chiller, and that's how they get to the chilled water or the cool. Any comments, any questions? Any comments, any questions? So that's how your system is put together.
Heating coils or doesn't matter?
Bigger chillers, yeah, bigger chillers can have multiple heating coils, yeah. At least one heating coil, big heating coil, and at least one cooling coil, but they could have multiple heating coils and multiple cooling coils. I want to remind you guys there's a fan on the supply here, and in our project we also have a fan in the return. So here's a fan that pulls the air out of the air handling unit and one pulls it into the air handling unit. Typically you need at least a supply, but the project that we have, remember we have 3 air handling units, right? And each one of them has a return and supply. That's why return and supply. You will have a fan here shooting the air in and a fan here pulling the air out into the air handling unit. Any comments, any questions? If you guys don't understand this one and you graduate from here, you'll be ready and you do design, you'll be confused all your life. Because you're going to be dealing with this system all the time. We don't design it, but we have to understand it. We must understand it. Any comments? So here's a cycle outside. Here's my inside loop, 2 loops, 2 closed loop cycles. And when I say a loop, it's a water, big water pipe, right? Blue indicates chilled water, red indicates hot water. Coming back. And they use compressors. They compress that refrigerant, my friend. By compressing the refrigerant, it increases the temperature, increasing the pressure, it reduces the temperature of the refrigerant. When you reduce the temperature of refrigerant right next to the water, it picks the heat from the water. That's how we get it in. And then all the heat coming from the room through this coil will be picked through the condenser, taken out to the cooling tower, shot up in the air, and come back. There's an outside air exchange because we don't want to kill you. You have to get you some outside air exchange. So they have a damper here that opens and get us in a day like this. We have an air exchange for us guys outside. It opens and gets some fresh air. They keep supplying the fresh air. All this is part of your building automation system. Your building automation system control this one, guys, completely. Bring fresh air, how many cycles of fresh air you need based on the code and so forth. Any comments, any questions? We have an exhaust air, guys. There's also here, you can take, to maintain the pressure and not have a negative pressure in the room, they can exhaust the air out or they can bring air in. You have to balance between the air in and the air out, right? To maintain the pressure in the building like this. So here's an exhaust. You can, based on the building automation system, you can shoot too much air in the building, too much pressure, you can shoot out, or you can bring air in to balance the pressure inside the building, or of course to get your fresh air to your building. You don't have walls and all that stuff. There's also a relief air and all this good stuff. So you can see all the interface, mechanical interface with the outside, bringing air from the outside, mixing it with the inside and so forth. Any comments, any questions? Any comments, any questions? Okay, so so that's basically what the cycle is, guys. And let me just go over where we interface. These numbers, can you see these numbers? All these numbers are electrical equipment that need to be powered. For example, and this will be on number 15 is a pump, boiler, pump chiller, cooling tower, pump condenser. All these, the ones that highlighted, from the boiler, need unification, you need a circuit. From the cooling tower, need a circuit or multiple. The chiller, need a circuit. The fan here, need a circuit. The in fan also need a circuit. Here's a damper, 2 dampers here, need a circuit. Here's another damper here, or a fan right in here, need a circuit. All these guys, here's an exhaust fan right here, also need a circuit. So that's where we interface, we come. So what do you need to do? You need to, so here's where you come into this picture. You need to provide a circuit. Here's circuit number 1 for the chiller. You need the cooling tower, circuit number 2 for the cooling tower, circuit number 3 for the boiler. Then your air handling unit, typically you have circuit number 4 for the air handling unit, and sometimes the ends have also here fan. It is number 5. Dampers, these dampers, guys, typically they heat circuits, but they take them from the control. All these dampers, they have circuits, control, circuits to open them and close these dampers. We have an exhaust fan here. Here's circuit number 5, circuit number 6. All these are, you required as electrical engineer or electrical designer to provide power to these equipment. The ones that I wrote in red, these guys are dampers, typically powered by the HVAC equipment control system. You could also, they are bigger dampers, we could provide them also with a power circuit. Do you see what our interface is? Pumps. So I have 6, I have another one 7, and another one here 8. All these are circuits. Did I miss any? 8 circuits. There's a pump on the boiler. A boiler, pump on the boiler here. That will be, that will be up above. So we have 7, 8. Where are we? Which number are we? 9. So you can see all these equipment lists that you guys got from Chad. When we started the project, that's where we get them from. When you become a project manager, Jeff, you're going to sit with a mechanical contractor as an electrical contractor and discuss the interface between you as an electrical contractor and the mechanical contractor. If you're like Egan, you are both, right? You guys run mechanical, electrical, so who cares? You know, but you still have to manage the teams and who's doing what, when, and where. Any comments, guys? Any questions? Any comments? Any questions? So that's basically here's pump 15. I will put this in the network for you. Really nice. I thought it's really nice. There's others that's not reheat coil, cooling coil, heating coil. It identifies all the components, guys, in the system for you. Identifies all the components in the system for you. Any comments? Any questions about the cooling system? Comments? Questions? Does it make sense? No? Yes? Do you see the big picture? Dunway, boiler, cooling tower, in the back, chiller, air handling unit, or units. Air handling unit or units. That's how you feed a typical big building. A typical big building. Smaller buildings, guys, smaller buildings, they take the whole system here and they put it in so-called rooftop unit, big rooftop unit. They put it on the roof, and that will have a coil to chill the water, as well as a heat, some type of heat element to give you cool heat all in one unit. They typically use it in smaller buildings, office buildings, smaller buildings, bigger buildings like ours at Dunwoody, the project that you're working on. Here's the system, 99.9% you're dealing with a boiler, cooling unit, chillers, and air handling. Any comments, any questions? Can I have thumbs up, Chad? We fully understand that one. I'll put this one in the network for you. Okay, so this is kind of the big picture. Let me show you another one that I thought that was really cool. This happened to be General Mills. Look at this one, chilled water pipe scheme. This is getting deeper, guys, into, remember how we said there are 2 cycles? Joe, there are 2 cycles of water. One is the outside, one is the inside. If you look at the bottom here, can you guys see, here's the chiller. They have 1, 2, 3, 4, 5 chillers to chill their building. 5 big chillers. You saw the chillers. All in parallel. They're running in parallel. They're all tied to the outside cooling towers. They have 1, 2, 3, 4, 5 cooling towers, and they have air separators, tanks to control the water flow and all this stuff. Can you see how it gets, guys, complicated? So this is, instead of 1 chiller, they're running 5 in parallel, and that's the outside unit. All these, that's how you chill the water and take it outside and get rid of the air, the heat outside. Here's the inside piping. The top one is the inside piping. And then You get the chilled water right here through heat exchange, and then you take 1, 2, 3, 4 air handling units. It's pushing this cold water through 4 air handling units to cool 4 different separate spaces in the building. Can you see how it gets bigger and bigger? So what's your job and my job? My job is look at all these pumps, right? Who's going to power these? Here's 1, 2, 3, 4, 5, 6 pumps need to be powered. Chillers, 7, 8, 9, 10, 11. 11 air handling units is 12, 13, 14, 15. 15 things at least that you need to be powering with that you need to power here, if not more. Meaning we need to supply power for them. Any comments, any questions? Any comments, any questions? Does it make sense, guys, how the system get bigger? They parallel. Remember, Jeff, how we parallel generators? When we run out of juice? Exactly. They run out of chilled water or hot water. What do? They run them in parallel. They run them in parallel. You can see the hot represent the hot water coming back. The blue always represent the cold water going into the air handling unit. And what they're not showing here is that big blower that blows the air right through it and take it through the ducts to chill that particular area. They have dampers to control the flow of air. This is the flow of water. Right there, handling unit, change the flow of water into a flow of air, and then you start using dampers to control that flow of air. Any comments, any questions? I want you guys not to leave here not knowing this at least. Any comments, any questions? So the top and the bottom of this project. The top and the bottom of this project. Let me just show you if I have it here, and then okay. Let me show you the list of the equipment. Lectures here. The list of equipment that comes with it. Now remember that this is here's all the pumps associated with the system that you guys have that we just looked at. Look at all the pumps associated. Here's the horsepower. The most important thing, guys, is this. So Jeff, when you deal with where did it go? There you go. When you guys deal with mechanical equipment, all the pumps associated with these 5 chillers that we talked about, they're all given right. All the information is given right in here. Can you guys see that? Here's 90 horsepower is 100, 100, 130, 1/3, a half, 200, 200, 200. What's the voltage? Can you guys see the voltages in RPM? The voltages for all these systems. This is what you get from the mechanical engineers for their system, and that's what we're supposed to power. We're supposed to provide a power, at least a fuse disconnected powering the equipment. These are the pumps that circulate the hot water, the cold water, the closed loop, the 2 closed loops, and right underneath them, guys, is the chiller and the cooling tower. And you get a list of chiller and cooling tower. Here's my chillers. Chiller 1, 2, 3. I have 3 chillers. And look at the voltage that they're running at. 4160, very high voltage. And the kilowatt for each one of them. This is the information that you need to size them for the size the circuit for it. Cooling tower. I have all these cooling towers, and the information that I need for sizing my cooling towers is my voltage and horsepower for your equipment, my horsepower and my voltage for my fan equipment. Any comments, any questions? Any comments, any questions? So this is as big as it gets in terms of cooling and heating system. And our job is to go size the system, right? So to get you back into warming you guys up, let me see here. Let me go back into my system. So that's what I showed you guys is a bigger system than this. But this is really the bottom line. Summarize the bottom line before I go through what detail here. We have a cooling tower interface with the chiller. Take the heat outside the building. And chiller interface with the air handling unit. Removes the heat from the building through the chiller to the cooling tower. We have a boiler who brings hot water into the chiller so we can heat our building, and a couple of pumps to control the flow of water in every system, and a couple of fans to control the flow here. So we have pumps, we have fans, we have chillers, and we have condensers. For cooling towers. Any comments, guys? Any questions for that? So that's what I wanted to start my class with. Let me just go quick over this, guys. This chapter talks a little bit, just a little bit, about the chillers and all this good stuff. Ventilations. Every building that you get into, guys, must be heated, cooled, and ventilated. That's it. You have to provide heat. The system that we were looking at is to provide you heating, cooling, and ventilation of the system. You can heat and cool through the chiller and the boiler. You can ventilate through the exhaust fans in your building. So that's a few things we're going to do. So ventilation, guys, exhaust fans. The exhaust fans are very easy. They are a big fan on a roof like you guys have. There you go. I want to go back into, so Jeff, part of your heating, cooling, and ventilation of your system is install this big fan, motor fan, that exhausts air outside the building to balance the pressure inside your building, or to balancing the pressure or the temperature, equalizing the temperature. So that's your exhaust fan. What's in the roof? How many of these do we have? This is, you guys have a new project. 5 of them on the roof. You're going to install these 5 on the roof. It looks similar to this. And my job and your job, guys, is to bring, here's a disconnect. Can you see the disconnect? And we're going to bring a branch circuit to feed this exhaust fan. What does it do for living? It exhausts air from the building as part of your heating, cooling, and ventilation system, or building automation system in your building. Any comments, any questions? Any comments, guys, about this? So that's your exhaust fan with your exhaust fan blower. Here's how it looks like, taking air out. You move your air, there's camber here, and you move your air, and your air will go right in here. Anybody knows why these are not pointing up? So the water don't get in, right? You see them all the time when we go to Allianz. I'm sure you, the ones who have been in the field, seen them. When you go to Allianz, guys, we're going to go on a roof. So you can look at these big boxes. It looks very similar to this, to exhaust and balance the pressure and the temperature in the building. My job is to come over here to the disconnect right here and power it. Any comments, guys? Any questions about that? Comments, questions? So that's my exhaust fans. In the building that we have, in our building order project, guys, we have 6 exhaust fans. Our building has how many exhaust fans? 5 exhaust fans. So what is Kerry? Remember how you said, Kerry, we can take a feeder up to the roof and feed it out there? There you go. You can take, the way they're doing it right now, they're feeding in separate feeders. They're coming into a gutter 1, and from here into a gutter 2, and from here into a gutter 3, and so forth. Here's how they're feeding it, each one from its own disconnect. I could have fed all of them, my exhaust one, from one feeder and tapped it based on the tap rules. Anybody knows what this one? That's your controller for your exhaust fan. Typically, guys, they have some type of controller so they can control the flow, sometimes speed control of them, even to control their speed, how much air they want to exhaust out of the building, but at least on up. Any comments, guys, about ventilating the building using exhaust fans? Exhaust fans. Your job and my job is to size this panel, the gutter, the conduits, the wires that feed this system. And the mechanical guys take it from the duct side and move on. Okay, now when it comes to the chillers, guys, we'll talk about chillers. Every time you have some type of a compressor in a building, there are these terminologies. We touched on these before, so shouldn't be new to you. We have maximum continuous current. We have rated load amps. We have branch, circuit, selection current, we have minimum circuit amplicity, and we have maximum overcurrent protection device. These are very important. Let me go over, I know we did a bunch of projects. The most important one, guys, you're going to encounter is this one. The minimum circuit amplicity, this is sizing the feeder. The maximum overconduction device, this is sizing the overcurrent protection device we're building. Can I have everybody's thumbs up, chat, before they understand that? That's minimum circuit amplicity, size the conductor, maximum overconduction device, size the overconduction device. By code, the manufacturer of a chiller or compressor equipment, they call it hermetically sealed equipment, which is basically chiller compressor. They have to put these two on the nameplate of the equipment so you don't have to do calculation. If they don't, then you're going to use this rated load amps and multiply it by 1.25, and that will size your feeder. And this rated load amps and multiply it by 1.75, and this will rated your overconduction device, and you go down. Any question, guys? Any comments? Any questions? Any comments? So that's what I want to emphasize. The most important thing about it. Then they have maximum continuous current. The manufacturer run the equipment. They measure the largest current that the equipment can handle before it blows off, basically, and they give a value of that. That's called maximum. Typically not for us. We don't use it a lot. For them, rated load current is. Remember, it's a percentage of the maximum continuous current. Branch circuit selection current, guys, because HVAC equipment have control and fan and compressors all in one big box. So sometimes they add all the amps and put them as branch circuit selection current or rated amps. Whichever is larger, you're going to use to size your equipment. So any of these have to be on the nameplate, you can size your equipment. But Jeff, don't cry too much because you can have the minimum circuit amplicity and maximum protection device planted right into your chiller. So all what you have to do now, provide a feeder with the same size based on the amps, no calculation done of minimum circuit and overconduction device. Any comments, guys? Any questions? HVAC equipment are they are special type. Why does the code separate them in separate article? They're special type of equipment. What they do, guys, they take the chilled water or the chilled refrigerant, and they run that refrigerant over the compressor water. So what happens if you run cold refrigerant over the compressor water? What happens to the water? Cool it down. When you cool the water down, what can you do to the water when you cool it down? You can abuse it. So these equipment can be run for a long time and abused. You can imagine all the compressor have to be cooled the building. So that's how the code treat them separate, guys, because the refrigerant part of the seal for the refrigerant will cool the compressor, motors, and so forth. Okay, so a few things, guys, about the maximum overconduction device rated by the manufacturers of they call it hermetically refrigerant compressor motor. So that's done by the manufacturer. Needed to be properly designed for the unit, not done by us. We don't care too much about it. Not on the nameplate. It's not on the nameplate. So this is just FYI only. The second one, the maximum, rated load amps, Jeff, is the most important one. You have to put the rated load amps on the nameplate. Rated load amps have to be on the nameplate, and it's typically 64.5 of the maximum continuous current. Maximum continuous current. You don't have to know that, but it is 64%, 64.1% of the maximum continuous current. And it's also on the nameplate, like we said. Then branch circuit selection current, guys, the manufacturers either give you a rated load amps or branch circuit selection current, whichever, and you're supposed to use it. Same thing. You can see it's very similar, and it's equivalent to maximum continuous current. 64%, 64.1% of maximum continuous current. What do we care about, guys? We care about minimum circuit amplicity, maximum overconduction device. If they're not given, they have to give you branch circuit selection current or rated load amps, and from either one of them, you can size, like we did the example that you did with before sizing. Minimum circuit amplicity, guys, this is done completely for you in the nameplate. It's going to be on the nameplate. The way they size it, like I said, you take 1.25 times rated load amps or branch circuit selection convection current, whichever is larger, and the size of conductor for you. No need to do it, it's already sized for you. Okay? Maximum overconduction device, maximum overconduction device. The way this, remember the code says 225 or 175%, and we use 175% if we don't know because we were conservative. So the manufacturer, they can use either 225 or 175 the size overconduction device. We don't care which one they use, guys, as long as they use it, put it on the nameplate, their equipment, because they know their equipment and we're protecting their equipment. So that's what they do, maximum over, that's the fuse or the circuit breaker size. How do they do it? They take this number multiplied by rated load amp or branch circuit selection current, whichever is larger. Any comments, guys, about these? Any comments? When we did the commercial project, if you guys remember, we went over this one too. Coil. Here's the coil. We keep talking about the coil, guys. Do you remember? Here's the coil, the typical coil. You can bring the hot water here. You bring hot water in here and blow the air, and then you take it back here. This is the in and out, and you blow air into this. What do you think from the other? You're going to get hot air. Hot air. If the opposite is true, if you put chilled water here, chilled water, and you bring it back to keep chilling it, and you blow air in it, what are you guys going to get out here? Cold air. That's how you get the hot and the cold in any building. Any question about the mechanical coil? They call it a coil. Don't get it confused with our electrical coil. Just a pipe and loop, because I've seen it looks like similar, and the water goes through it. As the water through it, you throw the air right in between all these coils. Any comments, any questions about this? Yes, no? No? Cool? Everybody understand that? Cool? Okay, separate overload device. This talks about the overload, guys. We size a lot of stuff for me about the overload. It just tells you the rules for the overload. Just very quick review. If your service factor is 115 or larger, 125. If temperature rise less than 40, 125. All other cases is what? 115. I wish you guys remembered that when we did the test. Some of you. Almost all of you remember, but one did not. Remember that how to size the overload. And I know we size them, so I'm going to skip on that one. And then aligning sleeves for the straight edge, we'll skip on that one. Typically not. The manufacturer, if they need to correct power, the manufacturer will add it as part of the package. Cooling equipment, guys, I'm not going to go through that. This is the mechanical stuff. You have the pulleys and the belt and deflection. You know, if you open these, they're driving. There's a belt that drives the fan. The way they interface, mechanically interface, the motor is mechanically interfaced with the fan. They have different ways, direct connection or through a belt. So if you're doing through the belt, you have to make sure the deflection is within acceptable range. Chilled water, we talked about the chiller, guys. I showed you multiple chillers in an example. Part of your refrigeration system provide cooling through the. This is why, Jeff. This is why they allow you to use separate coil and the chillers are special animals because the refrigerant medium provide cooling effects as it passes through the motor. You can't get this one from any motor. So the refrigerant cools the motor. That's why they call them hermetically sealed motors, guys. Hermetic motors, because they're sealed, they are cooled, naturally cooled. Okay, so what does it mean if you cool it? You can abuse them. You can abuse them a little bit more. So here's your chiller. You guys got into, you see the chillers, the different cycles coming in. 1 cycle, 2 cycles, refrigeration cooling in, right? And then going back to here, with whom am I going to pick up my friend now? Here's your motor, guys, and look how they bring the refrigerant right around the motor as it goes through the compressor. So when you bring that chiller, guys, and the chilled water or the chilled the refrigerant right around the motor of the compressor, what do you think is going to happen to the motor? It's going to cool it down. That's how they cool the filter, and they can abuse it a little bit more. If that's and that's how they're in the code treated differently, other than any pump that's sitting there, because it doesn't have chiller or refrigerant coming and cooling it. So it's specially cooled. Okay, so that's what I have, guys, about the HVAC. So we did heating, cooling, especially cooling. We did exhaust fan. There's something called precipitation unit. Jeff, when we went to the manufacturing, because when you cut things, you make a lot of fumes. So what they do is smarter than Chen, guys. They have a little machine that there sucks the air from manufacturing, filter the air, bring it back into the system, and all the fumes, exhaust the fumes out. That's, they call it precipitation unit. They call it precipitation unit. Typically in manufacturing, because you have a lot of fumes as you cut with steel and all the stuff, you create a lot of fumes and a lot of nasty stuff for health-wise. So they put it right next to the machine, sucks the air, clean the air, take the fumes out. If there's oil in the air, it flows it back and bring it to a different cycle. So that's what this is doing. Draws the contaminated in manufacturing air, removes the oil mist, because you always put mist as you cut, the smoke, the odor, and returns the clean air into the building. Special system, guys, for manufacturing only. Right by the machines as you cut through the steel. It takes the air, clean the air, bring it back into the building. It's not an handling unit, specialized. And then the coolant oil that you use, they can salvage it and reuse it for the machine. They have a reservoir. So what it does for you is clean your air, takes the oil in the air as you come through that steel. Imagine the smell and the odor and all that stuff. Get out the smell, the odor out. The oil that you cut through, you can gather it, you can reuse it, as well as the air, clean and bring it back. Any question, guys, about special unit? It's not a cooling tower, it's not an exhaust fan, special unit. The way they do it, guys, let's go directly into the drum. The way they do it is they have a high voltage here, DC, they use a DC, so they have a high voltage source, and they blow the air right into it. As they blow the air, they charge the particles with positive charge. So there's a blower blowing the air, imagine blowing air coming in. As the air comes into this this sheet or this coil that's ionized, it ionizes the air, make it positive. And then there are filters here. Can you see it's negative and positive? This as you blow it here, it ionizes it because it has DC on it. When it becomes positive, what happens if you throw it to a negatively charged filter, Jeff? It's going to stick to it. So it goes and sticks to it. All the bad stuff will stick to it, and all the air, the clean air from this side, will come clean air. That's how far as I'm going to go on in explaining how that baby works. To make this system work, guys, they have something called ionizer. Tungsten wire that they move it through to make it positive. Collector, these are your filters, collect all the junk stuff, and you have to have a supply power, which is provide you with a high voltage transformer with a bridge rectifier, some filter capacitor. So you take AC, filter it to DC, dump it across a wire, throw the air through it, charge your air positive, the filter is negatively charged. All these particles that's charged positive is going to stick to the negatively charged filter. And that's how you clean the air, if anybody care about that one. Any comments, guys, about this precipitator? So what's your job, Darren? Your job is to bring the whole system here into, you need to size overcap protection device and feeder, overcurrent protection device and feeder. My job is to bring this system, bring the overcap protection device and feeder. How do you size this system, guys? Based on recommendation from manufacturers, definitely. What size do they want? They will tell you the overcap protection device as well as the feeder. We can do some calculation. It has a high voltage transformer, a rectifier. So Jeff, how does it do? Look at this. It takes your voltage right here. Let's just say 277 volt. It pumps it up to a high voltage, I know, 2770. It rectifies it to a higher voltage. I don't know, I'm just going to throw a voltage here, like 750 volt DC. I might be off the wall here. Now we got DC, you put it across that mesh, and you throw the air through it, ionize the particles in the air, then the particles, as it ionizes, it sticks to the negatively charged filters. Now you clean your air. Don't you get amazed how smart people have figured that out? It really doesn't bother people, doesn't bother you how somebody sat there and think, how am I going to clean the air? Using charges. They're using charges. Adam, does it bother you? I know it's Valentine's Day and before it. And they make a whole field out of it. Now there's nothing for us to discover anymore. So for the machines that we have in our factory, guys, they have portable ones, exactly the same. The portable ones, except it does have a flexible hose, and you put it right there next where you cut and sucks the air and cleaning portable. You go from one location to another. I'm sure a few men like you and I have died in the process before we start filtering the air over the years. That's how it usually, right, Jamie? With all the fumes, and in the past, if anybody ever cared about cleaning the air, breathing it, have a cancer and die at 35 in the 1800s, not a big deal.
1800s, 1990s.
1990s too? Wow, yeah. The people still.
The company I worked for, they had a separate building. We all called it the dead building.
Yeah.
There were 5 people died before they were 40.
Cancer?
They were working with beryllium. And
Yeah.
if you walked into the floor, it was all oil and Nate was cleaning the air.
Wow.
With all the fluid and all that stuff.
Yeah.
They claimed they never caused it, but beryllium.
I agree. So it makes you appreciate all these inventions that they do. So I hear you. So that's basically, it's a portable one, guys. The only thing it's a portable goes from one location to another. And that's all what I have for you, my friends. Any comments, any questions? Just to quick summarize, my friends, really the most important thing is what I showed you at the beginning, is this. I will put this in the network for you. Please fully understand how the chiller, boiler, air chiller, cooling tower, boiler, air handling unit is tied together in the system. Right? It makes it easier when you talk to other engineers, how to interface with them. When they talk about a cooling tower, what the heck is doing for living a cooling tower, right? Makes it easier at least to understand it. Obviously, we don't size the mechanical equipment. There's a whole lot to size the ducts, guys, and the fans to drive how many square feet per minute and cubic feet of air per minute that you're going to exhaust out of the building. There's a lot of software involved in the air handling mechanism. Any comments? Any questions? My friend Chad. Cool. Okay. I'm going to give you 5 minutes, guys, and I'm going to go over a few things over.